For the introduction, solid mechanics is the continuum mechanics branch that studies the behavior of solid materials, especially their deformation and movement under the application of forces, change in temperature, change in phase, and other external or internal agents. In addition, this topic is very comprehensive and useful in order to enhance the abilities of engineers to help them construct structures in the world, such as bridge and many other in real life. This real, this real life example or application we select are intended to enhance the understanding of this course in solid mechanics too, to increase the accessibility of the concept and increase the subject appeal to students for a variety of background. As our case project, the there is one real life example that we choose and we will discuss in this uh, topic, which is bridge. So we have list five real example in which the first one is the bridge that we will discuss in this topic. The second one is the solid shaft drive. The third one is the skateboard. The fourth one is the thin wall pressure vessel, and the last one is the underground water reservoir. For the objective of this report or topic, for the first one, we want to study the condition of buckling of a column bridge. For the second one, we want to gain the understanding of the real world application related to the course of the syllabus, which is solid mechanics 2. The third one is we want to analyze the buckling of the column of the bridge and the buckling capacity on the bridge. And the fourth one and the last one, which is the fourth, we want to study to calculate the moment of inertia at the column and the critical load, which is the maximum allowable load on the bridge.
Selamat sejahtera. My name is Lingesh Kumar Analaki Tankavelu. My matrix number CD190252. Theoretical background. The equation we show is Euler equation. The L in this equation symbolize length and P symbolize the allowable load before buckle. As the length increase, the allowable load decrease. With shorter column compared to its thickness, one can infer from the same equation above that the allowable stress on a column before buckling increase as length decrease. The type of end connection for the column is another important factor in determining buckling stress. Based on the Euler equation, there are four types of column cases which the first picture in left side show. The picture show the difference for each column as the K and L can be described from the specific condition. The moment of inertia in column will buckle about the principal axis of the cross section. The second picture is stress versus slenderness ratio graph. When the slenderness ratio for a material with some buckling stress is more than the acceptance slenderness ratio, the Euler's formula can be used. Yet if the slenderness ratio is lesser, the Euler formula is invalid. That's all from me. Thank you.
Literature review. Study of bulking column of the bridge. In history, the theory of buckling of the structures found by the Leonhard Runner in 1757 with the path-breaking investigation of the bulking of columns. Euler's theory states that the stress applied in the column due to the direct load is small compared to the stress due to the bulking failure. Euler's theory column bulking can estimate the critical bulking load of the column as the stress in the column remains elastic. The maximum load of the column can withstand when it's about bulking called critical bulking load. This assumption is based on the theory that related to the point of the actual application, column material cross-section, and stress limits and column failure. Ideal column with pin supports. The column that we consider is an ideal column, meaning that column is perfectly straight before loading, is made from the homogeneous material, and upon which the load is applied to the centroid of the cross section. It assumes that the material behaves in a linear elastic manner, that the column bends in a single plane. In reality, the condition of the column straightness and the load application are never achieved. However, the analysis to be used to perform on all ideal column is similar to that used to analyze initially crooked columns and columns. 4.2 Having the various types of supports. The earlier load was derived for a column that been connected or free rotated at its ends. For example, case of the column fixed at its base, free at the top. As the column buckles, the load displaces D, and at X the displacement is V. There are four types of column based on the diagram below. The effective length was developed for the case column having the ends that pinned or free to rotate. In other words, L in the equation represents the unsupported distance between the points of zero moment. This formula can be used to determine the critical load on the columns. Having other types of support provide L represents the distance between the zero moment points. This distance is called the column effective length, LE. Obviously, for a pin-ended column, LE equals to L. In figure A, for fixed-ended free-ended column, the deflection curve was for to be one of the column that is the pin connected as the length of 2L. Figure B, thus the effective length between the points of zero moment is LE equals to 2L. The column fixed at its ends. Figure C, as the inflection points of zero moment L over 4 from each support. The effective length is therefore the represented by the middle half of its length, that is LE equals to 0.5 L. The pin and the fixed-ended column in figure D as the inflection point at the approximately 0.7 L from its pinned end, so that LE equals to 0.7 L. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and I am Muhammad Nazrul bin Abdul Razak. Today I am going to present the methodology. In methodology, our case study is about buckling column of a bridge truss. So we analyze the formula that needed to be used. So to validate the truss, we use online software to solve each truss. If we get the approximate value with the value of the software calculate, so our calculation is valid to our analysis. Secondly, from the force of the truss bridge, we calculate the critical load of the bridge using formula of critical load. Then we can get the buckling stress from the Euler's equation. Then we compare the minimum yield strength of the steel. If the buckling stress is lesser than the minimum yield strength, so the Euler's equation is valid. Alright. In our project, there are some assumptions that we made. So the assumption is the bridge column made of A36 grade steel. Next one is we assume one car is at most 3,000 kg. Next one is the bridge has a total length of 4 meter and 1 meter height. Next one is sectional area of column is 600 mm per square. Next one is factor of safety against buckling of 2. The last one is we assume that the pin-ended column.
Assalamualaikum and a very good morning to everyone. My name is Muhammad Firdaus bin Muhammad Lazi from Faculty of Mechanical and Manufacturing Engineering. As the last presenter from our group, I will talk about the discussion and conclusion part. For the discussion part, we choose the bridge design that derive from an online software. The nature of the material used on the bridge has used some assumption to achieve a bridge mode that very similar to real-world bridge application. Based on the calculation on the report, we can prove that the Euler equation is suitable to calculate the critical stress then yield strength of steel. To improve it, we also provide the online software analysis to validate our result. We also provide some suggestion to improve the bridge by using fiber reinforced polymer outer wrap on the column to increase the compression resistance. For the conclusion, the main objective of this project, which is to analyze the implementing method learned in topic column buckling, is already achieved. That's all from me. Thank you.